Alrighty, here we go. We are venturing on now into section 3, and you'll notice at the heading, I'm just writing 4-3A. That implies there's going to be a 4-3B. Yes, there is. The whole section is called Properties of Exponents and Powers, and we're going to tackle just some of the multiplying and dividing properties of powers. So that's why I'm calling it 4-3A. So go ahead and get that up on your heading while I chug-a-lug some coffee to get my body caffeinated and ready to go today. Okay? All righty here. Come on. Even my computer is acting slow today. What do you know? Go figure. Go figure. I don't know why I can't get this out of the way. Alrighty, so here we go. Our learning target today, I can. And once again, we are going to be evaluating expressions. So I can evaluate expressions. There we go. Using properties of exponents that we're going to discover today. Okay, using properties of exponents. Okie dokie. Here we go. All right, so let's say that I have this particular expression up here, 6 to the second power times 6 to the third power. And what I want to do is I want you to just think about what this means, okay? 6 to the second power means 6 times 6. 6 to the third power means I'm using 6 as a factor 3 more times. Now, clearly this is going to be a huge number, but really what I'm after here is let's just leave it in exponential form, which means this will be 6 to the fifth power. And the reason I can write it that way is because both of these have the same base. They're both a power of 6, so I can do that. Okay, now if you wanted to grab your calculator and crank out 6 to the fifth power, it's big, trust me. 12, it's probably 7, 8,000, something like that. It's big. But what I'm really after is write it in exponential form. What if you have a variable? C squared means C times C times C to the fourth, which is C, 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 C. Ah, well, we count all those up. 1, 2, 3, 4, 5. This time I get C to the sixth power. And I have to leave this in exponential notation because I haven't given you any kind of value to substitute in for C. So that's as simplified as we can make it right there. Okie doke. All righty. I've got to do one thing here and let's go ahead and switch. All right, look at this one. N to the fifth times N to the seventh. All right, well, this is getting kind of cumbersome. N. That's what N to the fifth means if we write it in expanded form. And then N to the seventh, oh, brother, 1, 2, 3, 4, 5, 6, 7. Boom, 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 boom. Okay, I got to count again. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. The same base, there's a much faster or easier way than writing this in this way. Write it in exponential notation. You get N to the 12th. What about something like this? Well, 2 to the 5th. 2, 2, 2, 2, 2. There's 2 to the 5th. And plain old 2 is 2. Or you might think of that as 2 to the first power. We most often do not write the first power because it would just be that term one time. Well, we count this up. This would be 2 to the sixth power. If I said evaluate that on your calculator for fun, you'd say, okay, that's 64. Okay. But I prefer you to leave it in exponential notation now so that you begin to see a pattern. Or are you beginning to see a rule? That's really what I'm after. Can you see the rule? Well, what if we had something like this? Now, clearly, This is going to be a ginormous number. There is absolutely no way in tarnation I want you to evaluate what this is, but I hope by now you're starting to see a pattern. 24 to the fourth power means I'm using it 4 times as a factor. And when I string along the next part, that's using 4 more 24s, my final answer would be 24 to the 8th power. Okay, are you starting to see the pattern here? There is a rule, and here's what the rule is going to be. To multiply powers with the same base, and that is the key right there. When you're multiplying powers with the same base, you simply add the exponents. Add the exponents. Let's go back and look at all the examples that we just did. Here's a 2, here's a 3. Same base, 6 to the 2 plus 3 is 5. C, powers of C. 2 plus 4 is 6. N to the 5th, N to the 7th. 5 plus 7 is 12. 5 and 1, that's why I purposely wrote that 1 in there, is 2 to the 6th. The last one here, 24 to the 8th power. So that means you should be able to put your pencils down and simply look at these and tell me what the answers are. Speed round. Here we go. 4 to the 2nd power, 4 to the 4th power. My base is the same. 2 plus 4 means 4 to the 6th power. You don't have to evaluate it. I want you to leave it in exponential form, okay? If it's a variable, same thing. My base is x. Raise it to the 2 plus 3 power. That is x to the 5th. Okay, how about this one? Oh, did I trick you? This one, x and y, these are different bases. Guess what? You cannot simplify this at all. Leave it as is. Different bases means leave it alone. It's fine just the way it is. Okay, that's the multiplying rule. But the key is you must have the same base. Awesome. Oh, what if you have a negative power? You know what? The rule still applies. All right, 41 to the 7th and 41 to the negative 3 means add those two exponents together. And you end up with 41 to the 4th power. Now, are you doubting? Are you doubting me and wondering, are you sure? I don't know about this negative stuff. I'm very, very sure. Think of what 41 to the negative 3 power means. We said negative exponents mean it's 1 over that particular one. And when I do this, it becomes one giant fraction that you're going to multiply. Oops, that's a positive. Shame on me. And here's what this means. 41. Oh, my stars. I had to pick a 7, didn't I? All right, how many have we got? 1, 2, 3, 4, 5, 6. Got to throw another one in here. That's in the numerator. In the denominator, you have 3 of them. And watch what happens. 41 divided by 41 is 1. 41 divided by 41 is 1. 41 divided by 41 is 1. I've run out of things in the denominator. Here's what's left. 1, 2, 3, 4. 41 to the 4th power. Sweet! That leads us into, what about dividing? Okay. What if you have a dividing problem, which I'm going to write as a fraction, that looks like this. 5 to the 5th power divided by 5 to the 3rd power. Let's think about it. 5 to the 5th power means 5, 5, 5, 5, 5. That's in my numerator. 5 to the 3rd power is here. When you simplify, 5 divided by 5 is 1. 5 divided by 5 is 1. 5 divided by 5 is 1. Here's what you're left with. 5 times 5 over 1, or in other words, 5 to the 2nd power. Sweet! All right, what about this one? 7 to the 5th power. Is this the same type of problem? I think it is. 7 to the 5th power, 7 to the 3rd power. If you write it and expand it out, 7 divided by 7 is 1. 7 divided by 7 is 1. 7 divided by 7 is 1. That kind of starts to become like a rap song. Give me something to do this afternoon. 7 to the 2nd power, because my denominator's 1. Nice. If you have variables, the same thing applies. The one thing that I'm going to tell you is that I am going to assume that x cannot be equal to 0. If it were 0, I could not do this problem because you cannot divide by 0, and I would have 0 in the denominator. That does not exist. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woohoo! 1, 2, 3, 4, 5, 6, 7, 8, 9. Jinkies. There's so much going on there, I'm going to change colors. Assuming that x cannot be 0, and if it's any other real number, then x divided by x is 1. 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 And I'm going to go faster than I can even talk right now. Because looky here at what is happening. You end up with my entire denominator is wiped out now is just 1. And on top, all I have left is just x. It really is x to the 1st power. Ding, ding, ding. Do you notice a pattern? You can just call it x because typically we don't denote things with just the 1st power. So here we have another rule. If you are dividing powers, the kicker, they have to have the same base. Then subtract the exponents. Go back and look here at our examples. 5 minus 3 is 2. 5 minus 3 is 2. 10 minus 9 is 1. Ta-da! Oh, my stars. Is it really this easy? Yes. When in doubt, you can always expand it out and divide, and you'll see what's left. But once you've done some and you start getting comfortable with the rule, you're saying, hey, I've got the same base. This would be 9 minus 2 power, or 9 to the 7th. Sweet. Here's your assignment. I've got it posted in Schoology as well. Notice this is in the textbook. Okay, we haven't done a whole lot of work in the textbook because you've had packets and you use your workbook a lot. So please note, these problems are all in the textbook today. All right? Excellent. I want you to dive into that. You should have plenty of time. Go ahead. Use the force. And may the force be with you.